Colorado National Monument is in western Colorado, in mesa and canyon country. The monument contains stunning views of steep red rock canyons and towering monoliths. Junipers and pinyon pine trees dot much of the landscape, many not over 10 feet tall, and twisted and knotted into striking forms. The ancient canyons have been shaped over time by wind and water, and our research is showing that much of the pinyon-juniper woodlands are ancient as well. Dr. Deborah Kennard has been doing dendrochronology work in the Colorado National Monument, dating trees throughout the park to determine how old the woodlands are. Dr. Kennard is primarily trying to determine the long-term fire history of the park, studying how often large, landscape-scale, stand-replacing fires have swept through. Kennard's work is different from that of most dendrochronologists, who often use fire scars to lay out fire history. Both pinyon pine and juniper are highly flammable, and they rarely survive fires, so fire scars aren't common. Also, pinyon-juniper woodlands are often characterized by the lack of fine fuels at the ground level, meaning fires don't carry from tree to tree well. So even with significant lightning ignitions, most fires in the pinyon-juniper woodlands only burn one or a couple of trees. But every once in a while, the fires become much larger.
Well, if the conditions are good, and this usually means ignition while there's a heavy wind event going on, the heavy wind can bend the flames, and so the flames in one pinyon pine or juniper crown can jump to the next crown, and then it becomes a crown fire that actually doesn't move along the ground. And then if the wind keeps up, it can burn hundreds of acres within a matter of hours. And so those are not necessarily common, but they do happen. So my question was, how long has it been since one of those major wind-driven fires, something that can cover hundreds of acres, how long has it been since one of those occurred in the monument?
The research showed that while small fires are relatively common, it's been a long time since large fires swept through the monument. The oldest juniper found so far was 958 years old, and there are many trees larger than the one sampled. So there are many trees that are likely over 1,000 years old, meaning there are parts of the monument that haven't seen fire in over 1,000 years. The data suggests that most of the monument hasn't burned in at least 400 years, and 60% of the park is not burned in at least 800 years. Kennard attributes the lack of large fires to the sparse surface fuels and the large expanses of slick rock and steep canyons that separate the mesa tops, acting as natural barriers for fire spread.
The park has been collaborating with me on this research by whenever they do any type of fuel reduction treatment, they will save the stem sections from the base of the trees for me to do dendrochronology work on. So basically that means sanding down the surfaces pretty fine so that the actual individual tree cells in the wood can be seen. And then that way we can count the number of tree rings using a microscope on these pinyon pines and junipers. And that way we can develop a size-age relationship so that when we come into the field we can look at a tree like this and using that relationship guesstimate how old one of those trees might be. So this is a juniper tree, and just estimating by the size of the tree, it looks like it's probably about 600 to 700 years old. The pinyon pine right behind it, which looks like it's about this big around, about 30 to 40 centimeters around, is probably about 250 to 300 years old. So what that would mean in this research is that this area around here has not burned in at least, taking the age of the juniper, around 600 years.
The research is being done in collaboration with the monument's resource management staff. The preliminary findings have provided support to the monument's approach to fuels and fire management, confirming that the pinyon-juniper forests in the park were within their natural fire regime. The findings regarding the age of the forest has also provided an important tool for educating the public about fire in the pinyon-juniper woodlands.
Dr. Kennard's research actually kind of validates some of the tools that we use, such as the fire regime condition class, where we go in and analyze all kinds of forests and grasslands, and we look at fire return intervals. And mature PJ is actually kind of a rare to infrequent fire vegetation community. And so that research shows that, when we have 600-year-old trees, that's perfectly all right. That's kind of part of the natural selection. So fuels management in that shows that, we're not going to go out here and try to restore these mature pinyon juniper communities, because they don't need to be restored. They're kind of on line with where they're supposed to be naturally.
Dr. Kennard's research has validated how old the trees are. Prior to that, we did not have any information that had been recorded as to the age of the trees. And as you know, how dwarfed the trees are in this landscape, we're often asked, how old are these trees? And prior to this, we were giving out numbers that they're about half the age that they really are. And people are just wowed. This whole idea that we do have trees that have been now documented that are over 925 years old. I mean, that's significant, and people are fascinated by that.
The Colorado National Monument may be one of the best examples of old-growth pinyon-juniper remaining. According to Ross Oxford, one of the biggest threats to the pinyon-juniper forest is not catastrophic fire, but cheatgrass, an invasive species which can quickly change the fire regime and lead to a conversion of the woodlands to a completely different ecosystem type. Currently, cheatgrass control is a priority for resource managers in the park, and they are working hard to ensure that the old-growth pinyon-juniper is managed and protected.